What's up, guys? Welcome to Calculus Club. In this video, we will be talking about one-sided limits and vertical asymptotes. All right, let's get into it. So first of all, we know that in order for a limit to exist, the right and the left limits must equal to one another, right? So here, for example, this limit exists, both the left and the right. As x approaches 1, both the left and the right limits are approaching to 0.5. Okay? Now, to write this mathematically, we're going to write this as you see here, right? That negative indicates the limit from the left, and a positive indicates the limit from the right. Okay? If you ever get confused on that, just think about a number line. Okay? Positive numbers are to the right, negative numbers are to the left. So here I want you to work through a number of problems, okay? Before you pause the video and try this, let's do one together, all right? So the limit is x approaches 7 from the left of f of x. So we are going to approach 7 from the left, and the left hand limit does indeed exist, and it equals to 2, okay? Now, pause the video and see if you can work through the rest of these problems on your own. All right, so I hope you paused the video and you tried these on your own. All right, let me show you now the answers to these. So the limit is x approaches 7 from the right. Well, we're going to approach from the right. And as we approach 7 from the right, we are approaching to 3. Okay? The limit is x approaches 7 of f of x. Well, we can see that the left and the right do not equal one another. Therefore, the limit does not exist. Okay? F of 7 means the y value at 7, which equals to 3. Okay, because that's the solid circle. The limit is x approaches negative 6 from the left. So we're approaching negative 6 from the left. As we approach negative 6 from the left, we are approaching to negative 1. Okay? The limit as x approaches negative 6 from the right is also negative 1. And that means the limit as x approaches negative 6 of f of x equals to negative 1. But f of negative 6 equals to 3, because that's where this solid circle is at. And the limit as x approaches 10 from the left of f of x. As we approach 10 from the left, it looks like we're shooting off to positive infinity. So this one equals to positive infinity. All right, so nothing too tricky there. So now let's think about finding a one-sided limit analytically. So imagine I don't show you the graph, and I ask you what's the limit as x approaches 1 from the left of the function you see there. Well, the first thing you're always going to do is try to plug in the 1, okay? So when you plug in the 1, what happens? You get 1 squared plus 1, which is 2, minus 2, which is 0 on top, which is okay. The bottom, however, if I plug in 1, I get 0 over 0, all right? Now, I'll talk in the next video about the different options when you get 0 over 0, but the first thing we know is that the function does not exist because there's a 0 in the denominator, all right? So that means we need to do a bit more work. Now, if you remember from the previous video talking about finding one-sided limits analytically, this one is one that we can figure out because the top can be factored, okay? So try to figure out the limit as x approaches 1 of all of this. Pause the video and see if you can do that. All right, so I hope you pause the video. Let's see. So when we factor this, we're going to get x plus 2 times x minus 1 over x minus 1. Okay, and remember that when we can factor out, remove this discontinuity here at x equal 1, and we know the limit as x approaches 1 of all this equals the limit as x approaches 1 of x plus 2, which is simply 3, okay? So this function is going to have a hole at 1, but the limit, the left and the right both approach 3. So if the left and right, if the limit exists and equals to 3, that means the left and right also must exist and equal to 3. Therefore, the limit as x approaches 1 from the left equals 3, and the limit as 1 approaches right from 1 from the right will also equal to 3. Okay, and feel free to graph this. Use Desmos. You can graph this. Zoom in if you want and explore it. If you're not, 100% on that. But now what we're going to do is we're going to get a little bit into vertical asymptote. Okay, so I've talked about this before. I'm going to remind you again. 100% of the time, if I evaluate a function at an x value and I get number over 0, that is always going to be a vertical asymptote, okay? 0 over 0, we're not 100% sure what happens there, okay? It's generally a point of discontinuity, but not always, okay? A whole point of discontinuity is a whole. I'll talk about that in the next video. Number over 0, always vertical asymptote. For example, let's think about this one, all right? At x equals 3, we would get 9 over 0. That means a vertical asymptote. And I'll show you this here with Desmos. X squared over x minus 3 looks like this. And we can see that there is indeed a vertical asymptote at 3. Okay, hard to see a little bit, but when I zoom in, vertical asymptote on both of these, and that lies at the line x equals 3. Okay, for this one, 7 over x plus 2, where is that going to have a vertical asymptote? You got it, x equal to -2. So at x equal -2, okay, you have a vertical asymptote. All right, so now let's talk about, let's imagine that we don't have Desmos, we don't have a calculator, and we are going to try to figure out what happens as we approach the limit from the left and right, okay? So when we have a vertical asymptote, for example, this function, the limit is x approaches 5 of x over x minus 5. At x equal 5, we know that we get 5 over, that's going to go to 5 over 0. So we know we have a vertical asymptote. Now what we're going to do is we're going to take a look at what happens as we approach it from the left and when we approach it from the right. Okay, so how to deal with this. So as we approach 5 from the left, that means we're dealing with numbers like 4.9, 4.99, 4.999, etc., etc. Okay, so let's just go ahead and jump to something really big here. Let's jump to something that's really close to 5. So 4.999, if I plug this in, let's think about what's going to happen. We'd get 4.999 on the top. Okay, on the bottom we get 4.9999 minus 5, which is going to be a negative 0.0001. Okay, if we divide that, well, this is going to be a number which is going to be like negative 49,000, I believe, 999. Anyway, it's going to be a really big negative number. And if I do something even more, like imagine if I have like 20 nines here. Oh, I don't know what's going on there. Sorry, I clicked the button. Hope that stops. Okay. When I plug that in, right, you're going to have this huge number, which is pretty much just 5. So let's make this easier and let's just make this 5. Okay, so I'm not writing so much. So 5 divided by a negative 0.0, and imagine all these zeros, right? And when I divide 5 by this number, I'm going to get a negative 5 and then a really, really big number. So I think you can kind of see here, as I get closer and closer to 5, what's happening is this shooting off to negative infinity. So the limit as x approaches 5 from the left is going to be a negative infinity on that, okay? As I approach it from the right, it's going to be just the opposite, right? Think about numbers really close, like 5.1, 5.01, and we'll just jump ahead, 5.000001, okay? If I plug in this number really, really close to 5, what's going to happen, the top is going to be this big number, and that's pretty much just 5, so instead of writing so much, I'll just write 5 on the top. Okay, on the bottom, I'm going to have 5.00001 minus 5, which is just a little bit bigger than 5, so it's going to be positive. So in the bottom, you're going to get all of this minus 5, which is going to be like 0.000, right? 1, and this is going to be a really big, I'm not sure how many zeros, and it's not important, but the idea here is that as I get closer and closer to 5, this is going to become bigger and bigger and bigger. So therefore, this one approaches to a positive infinity because this number is positive. Okay? Yeah, so the limit, of course, does not exist because the left and right don't agree with one another. If I graph it, it looks something like this. Okay? You can see that as we approach it from the left, we are going to negative infinity, right? This is an asymptote. We already know because when I plug in 5, I get 5 over 0. And as I approach it from the left, we're going to negative infinity. As I approach it from the right, we are going to positive infinity. Okay, so the idea is you just plug in a number really, really close to that asymptote and you take a look. Is it a really big positive number? Is it a really big negative number? And that allows you to determine if it's a positive or a negative vertical asymptote. Okay? So that is all for this video. Thanks for watching. If it helped you, if you could give me a like, comment, share with your friends. Those things all help me a lot to reach more students. So thanks for watching, and I hope you tune in for the next one. Bye-bye.